Hello students, welcome to Educate. In the last class of the chapter Amine, we have discussed about the introduction, that is what is amine, their classification, as well as about the nomenclature. In this class, we will discuss about the preparation of amine. Preparation of amine, that is very easy if you have watched the earlier videos of the organic chemistry of the YouTube channel Educate. Then you will find out that these method of preparations, that is reactions, are quite easy. Let's see here. One is here. First method is about the reduction of nitro compounds. It's nitrobenzene. Here hydrogen gas is providing there. Palladium act as catalyst and solvent here is ethanol. So what happened? Some of the hydrogen will combine with this oxygen form H2O, and the two hydrogen will combine with this nitrogen. Like that here, suppose here what will happen? H2 here. So this one will combine with these four hydrogen. That is, for these four hydrogen atom will be there. Two hydrogen molecule means four hydrogen atom. So four hydrogen atom combined with two oxygen. So that will form 2 moles of H2O. And the other two hydrogen that will combine with this nitrogen. Guys, keep in the mind that in the reacting vessels, there will be not only a single molecules, there will be a number of molecules. Here hydrogen gas is providing, so it is in abundant. So this two hydrogen atom, that means two hydrogen molecule or the four hydrogen atom, that will combine with two oxygen, form 2 moles of H2O, and the other hydrogen molecule will combine with this nitrogen and will form NH2. Now another reaction here about this one was we have also discussed in the chapter of aldehyde and ketone. Strontium here when combined with HCl. So strontium react with HCl. So that will form SnCl4. So how much? Nascent hydrogen, in this case 4, that will provide. So a number of hydrogen atoms, nascent hydrogen will be there. So 4 nascent hydrogen will combine with 2 oxygen and will form 2 moles of H2O. From other one, this nascent hydrogen is also there. There will be other nascent hydrogen. So 2 nascent hydrogen will combine with this nitrogen and will form NH2. So as a result, there will be formation of aniline. That was about when when strontium and HCl has been taken. One reaction is that. Another is also, that is when FeCl iron react with HCl. So again, about this reaction, watch out about this one. That is when nitrobenzene will react with iron and HCl, then what will happen? So what happened? Iron that react with HCl, and therefore iron react with HCl and there will be formation of FeCl2 or FeCl3, and as a result nascent hydrogen will provide. So the role of here in that means there is actually two reactions, two method of preparation. In one is that nitrobenzene reacts with strontium and conc HCl. Nitrobenzene reacts with the mixture of strontium and conc HCl. As a result, there is formation of aniline. Another reaction is that nitrobenzene react with the mixture of iron and HCl. So here again nitrobenzene forms. How is that? That when nitrobenzene reacts with the mixture of strontium and conc HCl, then strontium reacts with HCl and provide nascent hydrogen. This sum of that means 4 nascent hydrogen will combine with 2 oxygen and will form 2 moles of H2O. And the other 2 nascent hydrogen will combine with this nitrogen and form NH2. So as a result, there will be formation of aniline. Another reaction is that nitrobenzene react with the mixture of iron and conc HCl. The iron reacts with conc HCl, form FeCl2 or the FeCl3, and there it will provide the nascent hydrogen. This 4 nascent hydrogen will combine with 2 oxygen, will form H2O, and the other 2 nascent hydrogen will combine with nitrogen and form aniline. Okay guys, very easy it is. Most frequently formed is FeCl2. Less amount of FeCl3 also formed during this case. Now, next one is ammonolysis of alkyl halide. What is here? At the ammonia, there is lone pair of electron. So, lone pair of electron. So, it will want the positive charge. It will get attracted towards the positive side. So, ammonia here is acting as nucleophile. What is happening here? And in haloalkane, halogen is highly electronegative element. So, halogen will attract the shared pair of electron of the carbon of alkyl group. As a result, there will be development of slightly negative charge on the halogen and a slightly positive charge on the carbon of the alkyl group. As a result, this lone pair of electron here that will attract towards this carbon of the alkyl group and form substitute ammonium salt. This is RNH3 plus and X minus. Its name will be alkyl ammonium halide. It will be alkyl ammonium halide. That will form. Then after, what will happen? This RNH2. Then after, what will happen? Here not given. Okay, I am doing. That is R. Yeah, R NH3 plus X minus is there. So one hydrogen of this halogen, this NH3 plus, that will combine with halogen. So that will form RNH2 and HX. So primary amine will form. Again, RX, this means haloalkane, will react with this primary amine. So there will be formation of secondary amine because halogen will combine with one of the hydrogen, form HX, and this alkyl group will bond to this nitrogen. So two alkyl group will be bonded to this nitrogen. So there will be formation of secondary amine. In the same way, with this secondary amine, the another haloalkane will react. There will be formation of tertiary amine, and then after quaternary ammonium salt. Okay. When this one quaternary ammonium salt is here, this one when react with NaOH, then a primary amine will form. This one is, so that is here either this place or at the here. When that will be treated with NaOH, there will be formation of primary amine. Okay. So what is here during this course? There will be a mixture of primary, secondary, and tertiary amine. Reactions is quite easy, but maybe few students may feel difficulty. So I am doing this reaction by taking an example. Okay, solution here. I am taking the example of ethyl. That means I am treating the propyl halide with the ammonia. Propyl halide, propyl chloride, that's a common name, and IPAC name will be chloropropane. So let's see here. So here there is lone pair of electron at the nitrogen. So here ammonia will act as the nucleophile because it will attract towards the positive side. So ammonia will act as nucleophile. Halogen, this chlorine, will attract this shared pair of electron towards itself. So there will be formation of slightly negative charge on the chlorine and the slightly positive charge on the carbon atom. So here is slightly positive charge, here is lone pair of electron, that is negative charge here is. So this ammonia will attract toward this carbon. So compound become, so but this will be, when come, then that will be NH3 plus here and Cl minus there. The structure here is, then after I am elaborating this structure. This structure, actually a structure is what? Like this. And Cl minus. Like this one. This structure I have drawn here in the expanded form. So any one of the hydrogen will combine with this halogen and form HCl, and that's as a result there will be formation of primary amine. When this primary amine will be further treated with haloalkane, that means already there is a number of haloalkane molecules in the reacting vessels. So with this primary amine, the other haloalkane molecule will react. So hydrogen will combine with chlorine, form HCl. So valency of nitrogen will become destabilized and valency of carbon also become destabilized. So this carbon will get bonded to this nitrogen. So compound become so secondary amine will form during this case. Now again this compound will react with another haloalkane molecule. So here is hydrogen bonded to the nitrogen that will combine with this chlorine and form HCl. So this carbon will get bonded to this nitrogen. So compound become so during this course the tertiary amine will form, and again what happen with this one when another haloalkane molecule react, then what will happen, since there is lone pair of electron at this nitrogen, so it will, this nitrogen will get attracted toward this carbon, positively charged carbon. So here this nitrogen will get bonded to this one also. So nitrogen here and 4 haloalkane 4 alkyl group will bond there. Or directly I am writing here 4 and Cl minus will be attracted here. So the structure will be like that. Here will be nitrogen and the 4 alkyl group that will be bonded here. So here positive charge will appear on this nitrogen and here Cl minus. When that will be treated with NaOH, what happened? This chlorine will combine with this here. When that will be treated with NaOH, then this chlorine will bound to there. Okay, and then after here, so during those course, and one hydrogen from here that will get combined to oxygen. So that is here. Okay, hope this clear. Now let's see another one. Reduction of nitrile reaction here. So directly from here you can also do. Hydrogen is here suppose this one is this hydrogen. So what happened here? I'm writing. Watch out. I'm taking another example. By the example, like this one molecule. Its IUPAC name is butanamine. Well, sorry, butane nitride. IUPAC name is butane. E will written and nitride. With this butane nitride, that's react with hydrogen, and catalyst here is nickel. Again, keep in the mind that nickel here, catalyst nickel, that is the catalyst nickel that will provide the surface area to the hydrogen. So what happened here? One hydrogen will bond to this nitrogen. And why this one happened? Because nitrogen, there is a lone pair flat on nitrogen. In addition to that, among carbon and nitrogen, nitrogen is more electronegative than carbon. So this pi electron will be tilted towards this nitrogen. So obviously there will be high magnitude of negative charge. So this hydrogen will go there and another hydrogen will go to this carbon. So what will compound will form? Firstly, the compound will be this one, because when this hydrogen will bond to there and this hydrogen will bond to there, then to maintain their octet, this one pi bond will dissociate. This compound is called imine. When there will be double bonding between the carbon and nitrogen, the compound in which there will be double bond between the carbon and nitrogen, that is will be called imine. And again, the hydrogen will react with that. Again, one hydrogen to this nitrogen and one hydrogen to this carbon. So compound become it is. So during this course, there will be a formation of butanamine. Okay, easy. There is also two reactions. One is that is here is reduction of nitriles. That is here two reactions there is. One is that when the nitrile will be treated with hydrogen and in the presence of catalyst nickel, then what the reactions? About that we have discussed. And another reaction is when alkyl nitrile will be treated with the mixture of amalgamated sodium and the ethyl chloride. So let's see about that reactions. What is here? Again, we will discuss here. So let's see. All of you know that when sodium react with alcohol, then there is during that course there will be formation of sodium alkoxide and the hydrogen was releasing. So what happened? The role of amalgam here, amalgam means mercury. The role of mercury is that will provide resist the formation of a protective covering over the sodium. Now let's see what is here. As for example, I am taking again propane nitride. This one, what is actually happening here? Sodium react with ethyl alcohol. So sodium will replace this one. Hydrogen will provide from here. So hydrogen will be there. This hydrogen, some of the hydrogens, one hydrogen combined to this one, another hydrogen combined to this carbon. So there will be a formation of so firstly there will be formation of imine, and then after again this hydrogen will combine with this carbon and this nitrogen. So there will be formation of so during that course also there will be formation of butanamine. Okay, that is clear. Now let's see another one from reduction of amide. What is happening here? This amide, this is the reducing agent. So a number of compound, that means nascent hydrogen will provide by the lithium aluminum hydride, and there will be formation of amine. Very simple it is. Now let's proceed another reactions. This reaction is quite important. This is a name reaction, and it is quite important for the 12th board examination, for IIT main, as well as for NEET examination. Gabriel pethalamide synthesis. Okay, keep in the mind how pethalamide was formed. Keep in the mind in the chapter aldehyde, ketone, and carboxylic acid. That is here. So pethalamide has been taken, pethalamide has been taken, and with when KOH is there, taken KOH, potassium hydroxide. Then this potassium, then here this hydrogen will combine with this OH form H2O, and potassium will combine to this one. Why? There is lone pair of electron at the nitrogen. Why that happen? Again, watch out. Here again, here at KOH, there is positive charge K plus, it will dissociate into K plus and OH minus. Here, there is lone pair of electron at nitrogen. In addition to that, there will be high stress on this NH bond. So here slightly negative charge also, and here slightly positive charge. So what happened? Here is positive and this one is negative. So this hydrogen will combine with this OH minus. Always positive will combine with negative. And here is negative. So this potassium will bound to this one. So that formed here. Potassium pethalimide formed here. Then after react with alkyl halide. So potassium will combine with this halogen, form KX, and the alkyl group will get bound to this nitrogen. So that's what this form, and KX also formed. Then after this one here, then when you treat with NaOH. So what will happen? NaOH here, sodium here, and OH minus. Here is the negative charge. So there is electrostatic force of attraction between this one, Na plus and OH minus here. So what happened during that course? So ONA, here is negative charge, so that will get bonded to this one, because this oxygen will attack the electron. So here positive charge, here here negative charge, and to the carbon here positive charge. So OH will come here, O come and Na plus, this one come here, and hydrogen that will combine to this nitrogen. Same here another NaOH molecule. So here this oxygen will again combine to this carbon, and hydrogen left, that will be this hydrogen left, that will bound to again this nitrogen. So to this nitrogen, two hydrogen will get bonded, one from this NaOH and one from this NaOH. So as a result, there is formation of R and H2. Bond will dissociate from where then after. So that will form R and NH2. So it is amine, and it is 1 degree amine. And when ONA will combine here, then this compound will form. This compound form can be again synthesized. That means from pethalamide, you can again form this one. Okay. Let's see here. I hope this one is clear for you. Watch out this one for 2-3 seconds. How this reaction is taking place. Then after also I shall tell you how the pethalimide is synthesized, and from this compound sodium pethalimide, sodium pethanoate, how the pethalimide will further synthesize. Okay. Okay, so now let's see here. Firstly, let's see how is pethalimide form. Okay, one point before that, listen here. So what you have watched that only primary, that means open chain, amine of open chain has been formed. That means aliphatic amine can be formed by this method, but aromatic amine cannot be formed. Why aromatic amine will not form? So if there you will take on the place of that aryl halide. So aryl halide will be aryl halide that will not undergo nucleophilic substitution reaction with the phthalimide. That's why this one here, suppose here on the place of this one here, this one. So to prepare the aryl halide, you will have to take, to prepare the aryl halide, you will have to take here haloarine, like this halogen. Now in this halogen, dissociation of this bond will be here, dissociation of this bond will be difficult. What was happening here, actually suppose this compound. So here negative charge, here positive charge. So this was attracted towards, this has attracted towards this nitrogen. But in case of aryl halide, here no positive site, no positive charge will appear on this carbon atom. So when no positive charge will appear on this carbon atom, so it will not react. It cannot react here. It will not attract towards the nitrogen. Watch out once again. Why aryl amines here by this method, by the Gabriel phthalimide synthesis? Why the aryl amines cannot be formed? So when you reason here is that when you have taken haloalkane, then there is the development of positive charge on the alpha carbon atom. As a result, this alpha carbon was attracted towards the nitrogen, and as a result reaction proceed. Reaction proceed here because in case of a haloalkane, there is a positive charge on the carbon, so this carbon would attract towards this nitrogen. But in case of haloarine, due to this haloarine, there is no positive charge on this carbon atom, so it will not attract toward the side. If anyone will think that okay, here also halogen is high electronegative element, so why not positive charge? So guys, you have realized there, due to resonance, the electron of halogen was involved in the resonance. The lone pair of electron present at the halogen that was involved in the resonance, and as a result there be no development of positive charge on the alpha carbon atom of the haloarine. As a result, this one haloarine will not act as nucleophile, will not act as nucleophile. As a result, the aryl halide cannot be formed by the Gabriel phthalimide synthesis. Gabriel Okay guys, hope this point is more important. That's why I have discussed this one previously. Now, hot phthalimide synthesis that I have also discussed in the chapter of aldehyde, ketone and the carboxylic acid. But maybe someone has forgot that. By considering that, I am discussing again how the phthalimide synthesize. Okay, so let's see. To synthesize the phthalimide, firstly you need this compound, benzene dioic acid or benzene 1,2-dicarboxylic acid. This one, its name is benzene 1,2-dicarboxylic carboxylic acid. Its name is benzene 1,2-dicarboxylic acid. React with ammonia. So what happened? There is a lone pair of electron at the nitrogen. Here also lone pair of electron. So this nitrogen will attack toward this side. This nitrogen will be towards this side. So that becomes NH4 plus, NH4 plus, and here will be negative charge on the oxygen atom to which the hydrogen was bonded. So negative charge here on this oxygen and negative charge on this oxygen, because here hydrogen will go. So hydrogen will take, during that course, hydrogen will take its own electron as well as the electron of oxygen to which it was bonded. So as a result, there will be formation of here NH4 plus. There will be formation of NH4 plus here, and that will be here is negative charge. So that will be electrostatically bonded here. So structure will be here. Here positive charge. In the same way here also. Then after what happened? The two hydrogen atom which is very close to this oxygen, that will get bonded to this oxygen. In the same way here, these two hydrogen will get bonded to this oxygen. So from here H2O, from here also H2O. So what will happen? So 2 moles of H2O will form, and then after, so when 2 moles of H2O will form, so this NH2 will bonded to this carbon atom. This NH2 will get bond to this carbon. Same, when 2 hydrogen will go from there, then this nitrogen will get bond to this carbon. So there will be it will be called pathalamide. Amide it is. If you get confused, here it's amide, and the product formed will be called imide. IMIDE here. Go watch out on the spelling. It's IMIDE. It's AMIDE. 2 NH2 is bonded there, so that is called amide, pathalamide. And when there is formation of a ring, then that is called pathalimide. Okay. After that, what happened? Either the hydrogen of this one NH2 will bond to this NH2, or the hydrogen of this NH2 will bond to this NH2. So anything can happen here. So that will release as NH3. So the valency of this nitrogen will become destabilized, and the valency of this acylic carbon atom, that will also become destabilized. So this nitrogen will get bonded to this carbon. So when this nitrogen will get bonded to this carbon, then there will be formation of ring. Ring will get closed. Like that, this one is open chain here. If that will get closed, if there will be bonding between this one and this one, so there will be formation of a ring. So in the same way here, this nitrogen and this hydrogen and this NH2 will combine and form ammonia and H3, and this nitrogen will get bonded to this nitrogen, this acylic carbon. So here this NH, it is called pathalimide. Okay guys, that was. Next reaction is quite important. A number of times this reactions, the questions from this reaction was asked. That is by Hoffman bromide degradation reaction. So let's see here what happened. I am drawing this one by taking the example. Then after I shall tell you directly. Maybe if I shall tell you directly how this reaction was formed, then maybe you feel difficulty. So I am firstly doing this reaction by taking an example, and then after directly how's that there was directly you can consider. So let's see here. So compound here is I am taking the example of this propanamide. I am taking the example of propanamide. How's IPAC name? Suffix use amide, and of propane E will replace by amide. So its name will be here. Substitute suffix here for this one is amide, and the total there is 3 carbon. So that's why propane, from propane E will replace by amide. So that's why its IPAC, its name will be propane amide. Okay, that was how to write the IPAC name. Now let's see here how the reaction is taking place. So propanamide firstly take. That will react with NaOH, 4 moles of NaOH and Br2. So here bromine, this bromine, NaOH, this one. So how's that this happened? So to this bromine, firstly there will be formation of this one, these two, that will combine with this acylic carbon. Of the 2 moles of NaOH, 2 molecules of NaOH will combine with acylic carbon atom. So here is 2 sodium, here 1 carbon and 3 oxygen. Goes on the electronegativity. That means how to write. So most electropositive is sodium, then after is carbon, and then after is oxygen. Sodium here is 2, carbon is 1, and oxygen is 3. So that will be Na2CO3. So there will be a formation of Na2CO3, sodium carbonate, and then after here this sodium, then after this with this sodium, this bromine will combine, and this sodium here, this bromine will get combined with this sodium, so form NaBr, and this bromine will also combine with this sodium and form NaBr. So there will be formation of 2 moles of NaBr. What happened then after? Here is, so during that course there is this OH, hydrogen and OH. So maybe there will be formation of water, you may think, but actually that is not happening. What happened here during that course? So NH2 get bonded to this carbon, and this OH, this hydrogen, this OH. So this OH will combine with this hydrogen, form H2O. This hydrogen will combine with this OH, form H2O. So there will be formation of 2 moles of H2O also. Now this NH2 will combine with this carbon. So this one is here, CH2 and H2. So what is happening here? Initially the compound contains 3 carbon, and in the product the compound is containing 2 carbon. So during this reaction there is loss of 1 carbon. During this reaction there is loss of 1 carbon, as in the reactant the number of carbon atom is 3, and in the product the number of carbon atom is 2. So that's why this reaction is called degradation reaction, and this reaction is a type of decarbonation. Okay, so that is here. Clear? That's why it's called Hoffman bromide degradation reaction. Keep in the mind why degradation reaction, because in the product number of carbon atom is 1 less than that of the reactant. That was. Okay, these questions about that we will discuss later on. So previously, first of all, let's see how that done here already. So only questions left about that we discuss right now. Physical properties there. So from the beginning, one by one we will discuss all of them. So there, from here we have started, and then after is the first questions related to this topic is that one. So let's see how to solve this. Read the question. Okay, answer is given here. So answer is given here. So either I could write, then that there will be, if I shall solve this question by writing this one, then that will take more time. So better is that we directly goes through this, how that has been solved. I suggest you here, don't watch the solution firstly. You take your pen and paper and try to solve by yourself. And I hope any student will be not who could not solve this question, provided that he have learned the how to do the reactions of the previous chapter. So let's see here. So ammonia is reacting with haloalkane. So obviously what is happening here? There is lone pair of electron at the nitrogen, so it will get attacked over this side, including here. So okay, direct reaction is given here. So obviously there will be formation of amine. Okay, also I am splitting this one. So C2H5 here Cl and here NH3 plus. So this lone pair of electron get attacked. Oh, I have to again expand this one. Cl and here NH3 plus. So there is lone pair of electron at the nitrogen, and here is slightly positive charge on this carbon, slightly negative charge on this halogen. So this ammonia will get attracted toward this side. So as a result, there will be formation of NH3 plus and Cl minus. So of this one hydrogen will combine with this chlorine, form HCl, and NH2 will be there. So that is that has been shown. Only difference is that in the book the reaction has been written directly, and I did this one by stepwise. Only that is difference. Then after is that again halogen is alkyl halide will react here. So one hydrogen will combine with this chlorine, form HCl. This will combine here, as I did in the same way here. So secondary amine, then after tertiary amine, and then after here quaternary amine formed. Very simple. It is just like that of we have discussed previously. So this reaction is also same. You do by yourself. Better I suggest you take page and paper and then after solve again, and then after if you could not solve, then after again watch out the video. So this reaction done, then after let's see about the other reaction. Listen about this conversion. Okay, here also in book is given here, and why that I did again I tell you. So in the reactant here, number of carbon atom is 2, and in the product the number of carbon atom is 3. In haloalkane the number of carbon atom is here in this compound. In the reactant number of carbon atom is this one, or and in the product number of carbon atom is 3. So how to do? So to this carbon you will have to add one carbon. Okay, so very familiar you are when you have studied the haloalkane chapter, and here also. So NaCN here, NaCN that will be reacted with NaCN, because you will have to add one carbon. So here is the positive charge, here the Cn minus negative charge, and carbon-carbon bonding is stronger. That's why this carbon, because in Cn minus here it is the structure, there is a lone pair of electron at this nitrogen and at this carbon. So this carbon will get bond to this carbon because the carbon-carbon bond is stronger compared to that of carbon-nitrogen bond. So that's why propane nitrile form. Okay, how's the IPAC name? I think anyone will not feel difficulty. And then after you reduce them, how you reduce? By taking hydrogen and palladium, like that. So hydrogen will firstly amine will form, and then after amine. Or you can take the NaOH and alcohol. So again, sodium will combine there and hydrogen will get released from there. Or any one, a number of method is there. So when you reduce, so propane 1 amine will form. This reaction is same. Actually C6H5 CH2Cl here, and here again you have to form here number of carbon atom. Its structure is like that. And you will have to prepare so there will you will have to bond one carbon atom to this carbon. So how's that? Here open chain here carbon. Halogen is bonded to open chain carbon here, not to the benzene. So a cleavage will be easier. If chlorine would be bonded with the benzene, then cleavage of carbon halogen bond would be difficult. But here is chlorine bonded to the open chain carbon atom. When chlorine is bonded to open chain carbon atom, cleavage is very easy. So when you will take NaCN in presence of alcohol, alcohol means alcohol, mostly ethanol. So what happens? Sodium will combine with this one, chlorine, form NaCl, and Cn minus will bond to this carbon. So same, there will be formation of this compound. That is, structure of this one is same. CH2 and here Cn. And then after when you reduce the here by taking hydrogen and nickel, so that form. So this was, then after let's see another reactions, another questions. Listen here, in this questions here, it is you have to write the structure and IUPAC name of the amide, which gives propanamide by Hofmann-Bromide degradation reaction. Propanamide is this one. This one you will have to form. And what happened? During the Hofmann-Bromide degradation reaction, there be loss of one carbon atom. There be loss of one carbon atom. So in the reactant, you will have to take that compound which will contain one carbon more than this one. Okay, there amide you will have to form. So a structure reactant will be what? So that will be CH3, CH2, CH2, C double bond O, NH2. If you want to check first question about first part, I am here doing that so that you can check that form or not. So let's see here how the reaction is taking place. So that means this amide you will have to take butanamide to prepare propanamine by the Hofmann-Bromide degradation reaction. Answer is what? Butanamide here. Okay, how that this one? Let's see here. So just verify this by taking butanamide, there will be formation of propanamine or not. So butanamide take, and what happened during Hofmann-Bromide degradation reaction? There be NaOH and Br2. 4 moles of NaOH was there and Br2. This one. So one sodium combined with this bromine form NaBr. This sodium will combine with this bromine will form NaBr. Okay. So here this one form. Then after from here this NaO part that will combine with this acylic carbon atom and will form Na2CO3. When this sodium combined with this bromine, there was formation of NaBr, and this sodium combined with this bromine, then there was also formation of NaBr. So there will be formation of 2 moles of NaBr. And when this NaO, this 2 NaO will combine with this acylic carbon atom. So 2 sodium, 1 carbon, and 2 sodium, 1 carbon, and 3 oxygen. So that's why there will be formation of Na2CO3. And this NH2 will bond to this carbon atom. So that will form here CH3, CH2, CH2 and NH2. So propanamine formed. This one. Okay guys. Okay, very easy it is. And last questions, you do that. This question is same as that of the previous question, and I shall not solve this question till anyone will not comment in the comment box that he is feeling difficulty. If because solving this question will be quite easy, so I don't think that anyone will feel difficulty. So to solve this question, but even though there is only bigger chances that anyone will not, any one of them, of you, all the students, will not able to solve this question. But even though if will feel difficulty to solve this question, so obviously I shall make another video in which we'll solve this question. Guys, when a number of students will comment in the comment box that I want to solve these questions and this is my difficulty, so about that I shall make the videos. Okay, so study hard like that, study hard and make your future, because this one is the crucial situation. This period is the golden period for you, that in during this course till you are not appearing in the examination, how much labor you can do, that's much labor you do, and how much labor you will do, that much your wishes, you could fulfill your wishes. So study hard and thank you for watching our video. Thank you, Team Educate.